Alrighty, so today we're gonna have more of like just a conceptual review of uh, what we've been teaching over the last few months and sort of like why we've been teaching it. Um, yeah, so let's get started. So let's see some of our learning objectives today. Um, we're gonna be using like another Notes app example just to do this review of kind of like front end, back end, and databases, all of these. Um, we will be looking at the role and functionality of front end. So that is, we've seen it with JS, HTML, CSS. We've also seen it with React and Redux. So seeing how both of these were like tools that we could use to build a front end. And then we're also going to look at server-side applications and API development. So taking a look at that. Databases, so we had SQL and NoSQL, and then like why we use them. So for storing and querying data for our web applications. And then also recognizing that each of these components that are mentioned above, so front end, and then server side or back end, and then database, these are all very important parts of a larger full stack app or full stack system. And then we'll talk a little bit about like the final stages of development, so writing tests, which is what is going to come next week, and then also performing deployment. So that's after uh, that. Right. So let's just talk about the Notes app in general. Uh, so we can use this as like our starting point for doing that full conceptual review. So let's just imagine a very simple Notes app. It just looks like this. So there are some notes there. There's a sort of a submit button and a little input field. And a user can add in a note. So they added in Y, and then they click the button and that gets added. So this is just like, this is going to be the app we're going to be working with to talk about front end, back end, and then the database, all in the context of this app. And so for front end, we can put together all these snippets that we have seen. So like these three things, we can just put them into one and we can think of them as just one thing, right? Like that's just the front end, like that. So I'm just going to use that um, sort of rounded rectangle to represent that. And then within this front end, we can have these two functional units. At least that's how I think of it. We have the GUI, and then we have the architecture. And I'll explain what these are. So GUI stands for graphical user interface. So this is the user-facing part of our application for our front end, right? So this is what the user who's using this app, it's what they see. So that's like styling, the buttons they can click, input fields, and like all these things that enable them to interact with the application. Now, architecture, on the other hand, that's a term I made up, but because I was trying to look for like what is a term that includes internal logic involved in making user experience seamless. So, what is a term that includes like the code that makes the buttons and user input do things, and also stuff like local state, so where we keep track of things, and these sorts of things. So essentially, all the stuff that makes our code alive, what is some term I can find for that? And so ChatGPT gave me architecture, so I just put it there. But essentially, it's like it's all the stuff that makes the GUI actually do things. Like when you click buttons, when you type user input, when you interact with this. Also seeing data, like even seeing data in the GUI, that comes from the architecture. So it's sort of, that's just how we can separate these two things in terms of function in the front end. Does anyone have any questions so far about that? And we'll go over some examples of like some more examples of this as well. Okay, perfect. So this setup, this is not specific to any like sort of programming language or like framework. This is very general because we've seen this setup in two cases. So the first case, when we were working with HTML, CSS, and JavaScript, the HTML and CSS together, in some sense, could comprise the GUI, right? Because that was like the elements that we would see. Um, and then the JavaScript file that was being added was the architecture, because that sort of made those elements come alive, made them do things. So imagine a button. The visual component of that button is purely in the GUI. And then we have some function in the JavaScript file that's been added as an event listener to the button. So the event listener, that function is the architecture, like that it does something. Maybe it like adds a node or something like that. And then the event listener is actually the interaction between these two. So these two things do interact. I mean, they have to, right? The event listener is on change, something has to happen, so something updates, and then we see it in the GUI. Like there's an interaction between these two areas. And we've also seen this in React. So React is more of a special case. It's harder to separate these in React, but we can still sort of do it conceptually. Because both of the like GUI and architecture, they sort of exist together in the same file in React, right? Like in a component. Um, because like even in a component, you can have uh, parts of that file just for user interaction, like let's say, yeah, like a button or something like that. And then the architecture could be, you can directly just have the event listener added and then sort of the function there. Or even better, like use state. That's an example of architecture in React. And it exists inside the component that the person also gets to see. Now, they're not actually seeing the use state, they're seeing, um, they see the data. They might see the data, but that's being rendered in sort of the GUI. But they don't see like the sort of the use state itself sort of in the background. So yeah, this is just sort of at a very high level GUI architecture. We can sort of separate out these two things. And we can see that if we do that, then this is like a model. And this model can then be applied to these various cases that we have seen where we've built out sort of front ends. We built it out in the beginning of the course with HTML, CSS, JavaScript, and then more recently now with React and Redux, we've been doing that. And so that's why I thought it would be helpful to sort of bring this up. And yeah, these do interact with each other. So as that was mentioned, so that is sort of what we spent the first few months of the course doing. We also discussed mock API, where we'd end up storing our resources as well. So depending on the type of request, we would, and what data we send in. Right, so I see a question. The GUI is the front end and the architecture is the back end. So not quite. Both of these are actually the front end. So because all of this is front end, the GUI is like user facing. So it's all the elements that the user gets to see, like the visual and stylistic elements and how they interact with them. The architecture is the logic that makes that happen, but it still exists in the front end. Remember how in the React apps applications we built, we didn't have any backend. But we had like use state, and then we had like functions that did things with state and those sorts of things. So that was all architecture, exactly. So I'm actually okay. I'm gonna skip through these two. Oh, okay. Services user. Okay. So the user is just interacting with something. We have it. So I'm just gonna have this on the screen. I think it's my bad. I think the order is a bit wrong, but just so we can see this, because I will mention that We also use mock API. So you can see here mock API. We'd store some resources, and what we would typically do is we would have like services, and then there in services we have some functions, and those functions would send a request and get a response from mock API, as we see with this like double arrow here. And depending on the type of request and what data we send in, uh, with the address as well, we expect some predictable behavior. So if I send a GET request, so from services, if I send a GET request to here, and I send it to the right endpoint, right? So I want some resource. Then I get data back. And so, yeah, so in order to do this, we would have a services directory here, and then we would try to connect that to our mock API. And so this is just, again, this is sort of like visual diagram of what we built earlier. Does anyone have any questions about this, or even like about this mock API, like what this address is? Okay, perfect. So I'm gonna go back a bit because this will sort of fit into a scenario. So let's picture this scenario, which we did require to be implemented quite often. So a user enters the application for the first time, and the first load occurs. So there is a use effect, and it's sort of written in a way so that it's only gonna like load the application from scratch the first time. And so the user enters the application, first load happens, we have a use effect. So they sort of see it for the first time, the use effect runs. And what happens during the use effect is that the use effect invokes get notes. So that's a function that actually exists in the services. So what happens now is that the get notes function makes a request to mock API, which in turn sends back data. So that's that double arrow. And then the get notes function, which was here, returns the data to the architecture. And then, or the caller in the use effect, state gets updated, which then now in the GUI, we can see that because that change is rendered back to in the state. So the sort of the change in the state happens, it's re-rendered. So then visually we can then in sort of the display, the user can now see the notes. And so that is like kind of like a full picture of what we have happening, just using sort of this model. When we do that, and also provided we have mock API set up and linked. So this was sort of like the first bit of the course where we were just working with React purely in the front end. So if anyone has any questions about that, feel free to let me know. Alrighty. Okay, perfect. So let us continue. So now we're going to talk about backend. So naturally, though, there are limitations to using mock API. And one of those limitations is that mock API did not, it had these like built-in endpoints. And so it did not let us customize what happens between the request being received at an endpoint and the response being returned. For sure. So I see a question here. Can I explain the React front-end architecture? For sure. So like, I guess the best way to do that would be an example. So we can think of, I guess, Yeah, let's do an example. So let's say in the GUI, a user has a button, get notes. So they click that. And we have an event listener, or yeah, like on click, do something. So on click, that's the connection here. This way, on click, we have a function. And then maybe that function on click actually calls a function in the services get notes. Okay. And then that is actually the connection here that sort of gets notes from Mock API, it returns them. And then the sort of the view sort of the way back to here is that maybe we have in our use effect, use effect here, maybe we add that function call to the use effect. So if someone clicks get notes, it updates state in our use effect. We have a use effect here that updates the state, and then that actually causes a re-render of the GUI. So this is just like a sort of putting these things into two units separate is just another way to think about it's just to make a model of a front end and what is happening in terms of splitting between what the user sees and interacts with and what is the logic that's happening internally that is sort of hidden from them to make that interaction happen in a way that they expect or that they predict would be the case. Like when someone clicks get notes, they're predicting that that'll do what they expect, get the notes, right? So this is just a model of that. All right. So let's continue. So we were in here. Right. So one thing is that like we can use mock API, but there are limitations when it comes to using mock API. And one of the like limitations is that mock API does not let us customize what happens between the request being received at an endpoint and the response that's returned. So if I draw that here, imagine that we send a request. This is a request. It's caught at let's say a post, right? Here. And then there's a response. One of the downsides is that in mock API, this is hidden from us. Like we can only send data in and then we're like, okay, if it's the right sort of format, then it gets added to or properly, it's added properly to the resource. But we couldn't control what was happening here. You know, we couldn't say, in this scenario, I want this particular error to be returned, or I want to check for this thing, whatever it might be. And I think one example we used was imagine having a user login and cross-checking if the username and password are correct. Now, this is probably going to be a post request. So imagine it'll be a post request like this. And let's just put that in as login. So we have user data, we have username, and we have password. We send that in as an object, but the thing is that, you know, in mock API, we can't really do this because the post request for a login has to take in this information and then it has to cross-check with sort of saved data that is this username and password correct, right? It can't do that because all mock API's post request does is just add that in. It doesn't, there's nothing else we can do in a single request. Now, there was a way to work around this where probably you would do a GET request for all users, and then you could sort of like try to do a match the username and password with the all users and then return. But the thing is like this is a lot of processing that's happening. It's actually happening on our front end, basically. It's not actually happening here. It's happening in the front end code, like having all this processing and having to send other requests to do one thing that should be happening in something in a different request. So it's easier um, to actually look into making our own Express server rather than to use mock APIs, server and endpoint. So mock API basically looks like this, right? So it has a server that's running mock API, right? And it has these endpoints. I'll just put 3 endpoints: get, put, get, post, and then delete. And basically, this server can receive requests. And depending on the address of the request, it's either get or post or delete. So that is mock API. And then what we said is like we basically want to make our own server. This is our server. And we can also have these same endpoints. We can have more endpoints because we can write our own endpoints, right? So get, I'll just put GP and D. And then we have a request here, and we can actually write what we want to happen internally. So that's also one reason why we wanted to make our own endpoints and wanted to make our own server rather than relying on mock API to do things. Does anyone have any questions about that? Okay, perfect. All right, so I'm just going to clear the drawing, unless if does anyone want a screenshot? Maybe just in case, I will take a screenshot and leave it on the side. So, um, so in light of this, we use Express to make our own server. So I'm just gonna use this sort of rectangle to symbolize that. And we also added endpoints to server, which could handle the default CRUD request. So that is the server.js, and it's running on localhost 3001. And as you can see, we have some middleware. And actually, this line that I have here symbolizes us importing the middleware into the server. So this server example that I'm starting with is actually the one that already is using a router to compartmentalize endpoints so the endpoints are not actually defined anymore in the server. They're going to be defined in their own router directory. So this is the router version of our server code that I'm just showing here. Alrighty, so we can now put our endpoints here. So this is with a router. And so this is going to be the notes endpoint. So all our endpoints, so in this sort of file here, our endpoints will exist. And see that we also have a local variable at the top. So that's also to symbolize that at this point in time, when we were working with with writing backend servers, we were using local variables inside of like that router file or inside the router to represent the state of the nodes in our application. So I see a question. Can I do a small project to show us how a custom server is better in customizing than the mock API. So, I mean, I could, but I think the explanation should be sufficient of, like, for instance, if I have a login route, like, I guess I can, let me show this. So in this example, like if there's time, I'll try to do that after. But for instance, if we have a login route, we want to perform a login, we can't actually do that using mock API, because to do that, I would need to send my username and password information in a post request. And I would actually need that post request to cross-reference my username and password with stored user information in my in the resource itself, let's say for mock API. But mock API's post requests don't do that by default. They just perform a data insertion into the resource. So I can't do that in a single request. What I'd actually have to do is in the code that handles my login, I would need to do a GET request first to grab all the users. And then I would need to check, okay, do any of these users match? And then if they do, then send some information back. But like all of that code would just be in my services or in my front end. I cannot just very easily send a request that does that, because I can't customize what happens at an endpoint. I can only use endpoints with like the barest functionality. There's also other things like you can't add middleware. For sure. So you can't add middleware. Error handling is also very, like, you can't customize how you handle errors, again, through middleware. So there are a lot of like these things that sort of build up, and this is a reason also why we wanted to make our own custom server. And it's also just like no application, like full stack application, is using, or very few that I can think of, are using mock API. They want to make their mock API is more of a learning tool. They want to make their own server and endpoints to do it. So can we see a local variable in the code that we've seen? Okay, so another question. Can you show the local variable in the code you have done in class? For sure. So let's take a look at that. So maybe let's look at this Express server version 2, or maybe, sure. Now, as you can see, here's an example of a local variable. So actually, maybe I will show a router example. So this is an example that uses a router, and the local variable is in the notes router here. So it starts with that data, and that's sort of our local variable. Yeah. And actually, I think it is going to be mentioned here that one downside to having a local variable is that it's only while the server is running that this local variable persists with its information. So we create new nodes, we delete nodes, we update nodes, whatever we do, that is only persistent in the lifetime of a server running. As soon as we cancel the server, then as soon as we like cancel that server and run it again, it's starting from scratch. So that's actually one downside with this nodes variable, or with this local variable. Yeah, Samina?
So this local variable will still be used when we are using
I just see your hand raised, so feel free to ask a question.
Can you hear me? Can you hear me? Hello, can you hear me? Oh, okay, perfect. So my question is that when we have MongoDB and Postgres, oh,
Oh, sorry. I think, uh-oh, my bad. I think my audio was very low. Okay. Sorry about that.
Can you hear me now?
Yes, I can hear you.
Okay, perfectly. So my question is that when we're using MongoDB or Postgres, do we still use this local variable?
Um,
I'm,
that's a
I'm
great question. So we'll actually get to that very shortly, but we actually removed the local variable. We don't have it anymore
okay.
when we use MongoDB, and I'll actually show what happens. Um, yeah, sorry, my audio was very low. Did anyone else have a question earlier, like through the like the voice through odd, and then I wasn't able to hear that? Okay, all right. Yeah, sorry about that. My I put an alarm on my computer so in the morning. So I think I like put it to very low volume and forgot to turn it up. All right. Um wait, where were we? Okay, so this is sort of where we are right now. And then um we often used that REST extension to send requests to the running server. So I have the double-sided arrow just to symbolize request response. Because these were being sent to the endpoints that were running in notes.js, right? So technically, they would be sent to the server here because the server is importing these routes, but I just put it sort of here. So we could use the REST file as a tool to do that, to send these requests and get responses and sort of do that interaction with the running backend server without needing a user interface. So alternatively, we could also do this. So we could build a front end. And remember, when I put this front end here, I am referencing what we saw before. So I'm referencing, uh, if anyone can see that, I'm referencing this, like this whole thing, the colors are going to always match, by the way. So the colors are going to match from slide to slide. So this thing here is referencing this guy here. Let's perfect. So that is the front end there. Oh, also, I guess this is a clarification question. So given what we've seen on the previous slide, what part of the front end would be sending the request to the server? Like, where would this be coming from? Yeah, so yes, so it is in JavaScript code, but there's perfect. Yeah, so it's an architecture, and I guess more specifically, kind of like what would we? And it doesn't have to be like this, but like what might we name that directory where we would put those sort of functions that are going to send those requests to to the server. Right. So yeah, so we called it, that's correct. Okay, good. So I see the answer here. We called it services. So that's often where we had it. It's just like a general place. And the reason also why we make it a directory is just so if we have multiple resources on our server, we can separate those out in different files inside of services, just so it's a little bit more neater. Okay. Right. So it was mentioned earlier, what do we do with the local variable and how does that work? Like, how does the local variable relate to when we have a database? So that's a great question. I think we're going to cover that now. So we didn't end at the previous slide. One problem with that approach is that we're using a local variable to store our data. So that data does not persist in any way because it only preserves changes as long as the server is running. So once you cancel the server, you're starting over from scratch. Now, in order to address, now, by the way, this is sort of in our approach. There are actually other ways to do this. So we could actually keep this and make it persistent. There is a way to do that, but it involves a lot of overhead. Um, File reading, file writing, like, because I'm thinking technically we could write when we cancel our server, we could have some command that writes, like before we cancel our server, um, it writes like all the changes in the variable, it writes it to some file. And then when we start the server, it just reads from a local file. So we could do that, but um, it gets challenging when we have more complicated servers with more resources and things like that. So that's a scenario where um, just having a file that we read and write, read from and write to could work in a simple server with like one or two resources. But if we have many resources and then, you know, especially like an SQL server where there are relations between these resources, then it's actually very tricky. So then it's better just to have a database handle that. Um, so I see a question, what is the local variable? So the local variable in our notes router is kind of like, I guess here's an example. It's kind of like these. So it just stores the data that's on our server, or I guess in this case, it's the notes data, because we only have one resource and one router. So it would just, in this case, it's just an array of notes. But that is the array of notes that that's the data we're working with. It's the data that exists here. And then through these requests that are sent from the front end, it's also the data that the user sees. And if we use our own REST, the sort of REST extension to send requests, it's also the data that we get to see very easily through sending these, and getting responses back. Okay, so, right. So when it came to databases, we wanted to use, so we covered both SQL and NoSQL. So we still have our server. It looks like this, and it's running on localhost 3001. And actually, this is important. The server is running at this address. So it's running on our machine. So I think that just to keep that in mind, and I'll come back to that later. We by default, so we have our database here, SQL or NoSQL. This diagram works for both. And we perform our connection to our database through database.js file or a config file. It's quite general how this might be. And then depending on which type of database we use, remember here, we either are working with Mongoose or Sequelize. We import it, and then we have some like Mongoose or Sequelize object that is going to be initializing the connection in this file. And then we export this. This is exported wherever. And we can trust that because this file, the export is happening at the end, it's also exporting the same initialized Mongoose and Sequelize object that we perform the connection on. So there's like, that is how it sort of, we can trust that in that object, it is referencing that a connection has happened. So this export, wherever we export it, now in this case, it's actually going to be used in our models. So we're going to define a note model, and I have this line here because when we define the note model, depending on the type of database we use, SQL or NoSQL, we are using Mongoose and Sequelize to make that model definition. And the reason why we do that is so, well, for one, through that, this model inherits some methods that allow us to grab information from the database, update, deletions. Those are all sort of inherited in the model that we define because it is made through Mongoose and Sequelize. And also, sort of within that object, there's that connection. Okay, so that's just That's why we had that there. And then in turn, so then this model is also exported to our router. So it's used in our router. And then, of course, we import our router back into server.js file where we add it to our app. And then, of course, we have the middleware as well. So that was just, middleware is kind of unchanged. But the important thing is that the model is made using this Mongoose and Sequelize, which are these sort of libraries or frameworks that give us this functionality. It makes things a lot easier to do. And because they're defined in that way, and because we have initialized connections on the same objects that we're using to define our model, be it Mongoose or Sequelize, we then have access to some, again, as I mentioned before, we inherit methods in our model that give us access to the database. And that's what we use in the routers. So if I can show an example here, for instance, in MongoDB, being able to do note.find, this is not like a method that we get. Like this is from mongoose.find or .save, right? So these are methods that are here in this case. These are methods that are coming from Mongoose, or let's say Sequelize, right? .find all, right? So these are also Sequelize methods that come from how we defined our model. And I think that's the only one I have there. Right, because these are all to-dos. So does anyone have any questions about how that is working there? Yeah, Samina?
So I'm trying to understand this models thing. So you said the mongoose and the sequelize are over there, and it inherits those find all those functions of mongoose or so in it you have note.js. It's a singular. That is that like before any if you want to send if you want to, for example, put a note, so then the notes the notes.js will send it to the note in the models, and that is going to do the whatever post put thing into the database.
Sort of. Actually, I think that's a really good question, and let's go over that. What is the chain of imports that make this happen, right? I guess, and that would be let's look at that. So, sure, let's use MongoDB as our example. It's the same for Postgres as well, but we'll use MongoDB. So, as we can see here, so notice here, everything is fine. We're not referencing, I think it's at this point here when we import the notes router and we actually add it to our route here. So then we go to the notes router and notice that at the top of the notes router, I'm importing note from the models, right? So then let's go to the models, and then the models at the top, it requires from this database file, and then this database file. So again, this is using the mongoose.schema. So this is actually creating our note, but I'm importing mongoose from this database file. So if I go here, then here, this is like the default import of mongoose, and then I have my database URL, but then I perform my connection here, mongoose.connect database URL, and then I export this mongoose, not this one. So maybe I could put like X and then export, oops, X there. But it's the same one. So I'm exporting this mongoose. So we can see there's almost like a chain of requires that take us all the way back to performing the connection to the database. And then we're like, from here, I get it here, I use it to make the model, the schema. I export that back, I get it here, and then of course here it's being used in these methods. I return the notes router back to here, basically. So it is this sort of, there's this almost a sort of chain for MongoDB, and there's also one for PostgreSQL. So, and because of how the code sort of is sequentially executing, we can trust that, like some of it, there is some like asynchronous stuff built in, like it takes time to make the connection to the database, like, but what I think is that I think these frameworks also handle that asynchronicity. Like they make it work. There's probably a lot of like behind the scenes stuff happening to make it work as expected.
So note is making the schema, and notes is
Exactly.
doing the request, the post request get request.
Exactly. This notes plural. That's
Sure.
the router. Yeah. And then in the schema, that's like this is the first place where we send the request to the database here. Like, or sorry, this is the first place where we are making the connection to the database just through the import that we require is the one that connects. So it is sort of this like chain that's happening.
So in this chain, so when we are when the database, when the note is being executed, so it's creating the schema, and schema will create, based on the schema, the tables are going to be created in the database. So that should be done just the first time, right? Does it,
Oops.
why does it have to then be linked through the note? Uh, why can't notes go directly into the database after that?
So creation of table, like this is MongoDB, so it creates collections. So MongoDB will by default create it. For in PostgreSQL, it doesn't create it by default. We actually need to create the tables. Um, Sorry, can you repeat your question? I'm a bit.
My My question is that in the picture that you just showed us, so we have nodes connecting to note, the route is connecting to the model, and then the model going through the database.js to the database, right? So the models is where the schema is developed, is being defined. Once the schema is defined in the beginning, and based on the schema, the database creates the tables, then why do we still need to go through the models route? Why not the routers go straight into the database?
Oh, I see. Okay. So because right, just saying why can't the routers go directly to the database?
If no more schemas are needed to be created.
Right, right, right. So that's a good question.
Because each time it is going through it, isn't it like running this code again?
Right. So I think, yeah, that's a good question. Hmm. It might be. But the thing is, actually, I think once the server is running the first time, it sort of creates these references. And then it's just at that point, it's just listening once the route has been added. So I think it only happens once when you run it. When you run the server, it sort of makes these connections and it happens once. Now, the reason, like we could, technically speaking, we could move all this code and just have it here as long as we get to use this note, basically. This is what we use that has these built-in methods from the Mongoose schema. But we need to define a schema so we can use these methods like .find. There are a few more, note dot, bulk save, bulk write, delete one. So these methods we do still need, they need to be defined through the schema. But you're right, like we could technically put this here as well. Now, as far as it running more than once, as far as I know, I think it would only run once when we start the server. And then after that, that's sort of saved. But yeah, I'm not too sure about like the internal workings of how this is running in like in Node. It would be interesting to see like in a Node, um, maybe we could put breakpoints here and look into that. But I'm not, even if we put breakpoints here, I don't think that would actually show us what you're asking. Because it would be like the breakpoint would be here, but it'd be like, okay, only when we send a request, then are we actually going to be caught here. But yeah, as far as your question goes, I would say my hunch is that it only runs once and it makes these and it sort of saves these. Because this local variable that is requiring, this is probably some reference it makes in the memory. And so I think as long as the server is running, it's only really making that once, and then it's just going to reuse that when it needs to, when we catch requests at these various endpoints. Yeah, that's a really good question, though. Right. I hope that was an all right answer. Um, Definitely something to look into, though, for sure. Alrighty. So, uh, and again, even with, oh, actually, one more thing I do want to show you all before we continue. Remember I had this, so because I mentioned that the MongoDB, we don't need to worry about, because, well, it's not tables, it's collections, but we don't need to worry about that. We can trust in MongoDB. When we send our first request, it will just initialize the connections and it'll do, sorry, collections, and it will ensure that that's fine. But one thing that we were working with in Postgres was that if we don't have our tables and we send, let's say, like a GET request or a post that creates an entry in a table, when we use Postgres, it'll actually give an error like this table does not exist. So we actually need to initialize the Postgres beforehand. So here is an example. And mind you, this is an example that's totally separate from our running server. It's just a file that makes use of the model, which, so this, right? So this file, we grab the model from notes, and notes gets the data, the SQLize from database, which performs the connection, and then exports that SQLize object to here. Here we have it here. So this initializes the connection. We export the note. We import it into this file, create notes, and we use this method note.sync, which syncs the model to the database, that is, create the table. And then, so this is a promise, right? So it promises a model. So then once the table is created, then I do a bulk. So I insert 3 nodes. This is sort of like bulk creation into that database. And mind you, to run this, I just type in like node create notes. That's it. I just use node to run this file. It's totally separate from the server running. So I just thought I'd mention this. It would be a good thing to mention. Yeah.
Can you show the SQLize file in which the SQLize is mentioned? Yeah, over here, the dialect module, what is, because I was doing the SQLize part and the options that were given in the documentation were different. The SSL, what is all this?
Yeah, I'm not too sure what this is, to be honest. I think that so SSL is,
Security, right? For the,
yeah,
it,
so it's
why
a way to perform the connection. I'm not sure what dialect module is, to be honest. I think this is just something that is used to make that connection, but I'm not too
It
certain.
says PG, and PG over there, there's a constant variable PG, it requires PG. PG admin? Is this mongoose or PG?
I don't know if it is short for PGI.
Postgres, this is Postgres, this is Postgres. See database URL,
I can,
Postgres.
yeah, I'm actually not sure. I don't know what this is short for. It could be Postgres, but it might be something else.
Yeah.
Yeah. Also, one thing I'll mention, this authenticate, this is not actually required. Like this is not, it's not required to perform the connection, by the way. Because here, remember here, oh well, I did have the authenticate. Okay, let's actually try this. So I think my database, if I didn't cancel it, let's comment that out just to see, can we confirm that that's not required? CD lecture examples, CD PostgreSQL version 3. Okay, and let's run node create notes. Now it might say, right, so it creates it. Now I already have this table, but I'm just doing this to show that this authentication is not actually required to perform the connection. It just tests a connection to the server. So that's why that console log is there. But like for instance, if I remove this, if I uncomment this, so actually let me do that. And now if I run it, it should say successfully connected to the server somewhere. Um, not say it. Right. I don't think it says it because it's not actually running at any time by default. So already it was not running. It's not being, so when I run this, that's fine. It was not like this bit is not actually required to perform the connection to the server. It's just authenticates or it just tests our connection by trying to authenticate, but it doesn't perform the connection. The connection's performed here. Remember, I'm just mentioning this because by default we were getting this. Now the reason why we're getting that by default was because I put this function here in the server. So when we started the server, if I'm going to do node server, that's why we got that here. But I could comment that out and we will still get this executing select as result. So this is actually the default. They perform some query just to check that we are connected to the server. I think that's built into like, that's probably something built into this here that sort of shows on our terminal. Interesting. Okay, actually, no, it's not. So it is this authentication that I think it is the authentication that gives us this thing here to test it. But I do want to see, because I did say that that's not needed. So I want to see what happens if I do that. So if I run it, but I don't have that. And now I send a GET request. Okay, so it's still, the connection happens. I just don't see that. Even without testing it, the connection still happens. And just to check it here, I sent a request to my notes table. So, right, so there are a bunch of notes because every time I ran this create notes file, I added 3 notes and I have 9. So that's because I ran it a few times. Okay, so does anyone have any questions about that? That whole thing was just me checking if like, is this needed to perform the connection? So it's not, just to confirm that this bit of code here, which really is this function, this authentication, is not necessary to make that connection. So that was that bit there. And then, yeah, I just used a REST to make a request, and I got that response, which was just my notes table. And then also, actually, what we're going to be doing, the assignment tomorrow that's going to be released is this bit, building a front end that now lets the user interact with, technically they're interacting with a database indirectly through the router. Okay, so we've seen the front end and we've seen the back end. We've seen backends without database. We've seen backend with database. We can sort of put all these together in one picture and we get the following, these three pieces. We have the user, we have the front end, we have the back end, we have our database with that connection. So this is sort of big picture what we have. And a user goes to our application. So let's just go through a scenario. So the user goes to our application for the first time, which triggers a use effect. And in turn, we have some function in our services that sends a request to the notes router in our backend. And our notes router in turn at each endpoint makes use of these models here, or the notes model that we've defined to perform the CRUD interaction with our database. So CRUD is short for create, read, update, and delete. So it uses that to make that interaction. And then the chain of calls eventually returns back to the user. Oops. Sorry, back to the caller in services, and then back to the use effect where we update local state in our front end, which triggers a re-render. And then that re-render is reflected in the GUI, which the user sees. So this is, again, I guess this is sort of what we have been working towards this whole time. And we've seen, this is the full model. And throughout the last few months, we have taught sort of these compartmental pieces. So we first taught the front end, then we taught the back end, then we added the back end with the database, and now we're seeing the full thing. Now we haven't actually implemented this yet. So actually the tomorrow's assignment, right? Because assignment 1 had us build the backend. Assignment 2, this mini project part 2, had the connection to the database, and part 3 will be making the front end. That now lets a user very easily, by clicking buttons and having interactions, make use of this currency converter application. Okay, so does anyone have any questions about this? Awesome. Yeah, definitely. I think, having things like visually shown with their connections, like sort of in one place, helps put this into perspective, each part. And now we can almost see like, okay, this was the first few months of the course. Because the front end is actually quite complicated, because to do that, we have to learn JavaScript, we have to learn HTML, CSS, React, right? And then the back end is sort of like just JavaScript and some of these libraries, which are also just JavaScript. Yeah. So see, do the web projects usually built by doing the back end first, then the front end? That's a good question. I would say it it depends. It depends on who's building it. Yeah. I typically actually, so if I build something, I will actually start with, hmm, I would say it might depend on the project. If it's really complicated, I might start with the backend first and database and have endpoints. And I would probably plan beforehand, like what data am I working with? The front end is actually planned first, probably, like in terms of user navigation through the site and everything. And then that is used to then make to actually code the back end, because they have to think like what endpoints do I need to support this? What models, what service, like what models, what routers, what database tables do I need to support this? And like that is all built, and then they build a front end that makes that interaction. Um, yeah, it's a great question. All right, so let's take like a 5 minute break, and then when we come back, we have one more slide, but I actually want to draw something that will put so we'll see what the rest of the course will cover based on this. So let's take a 5 minute break, and then when we come back, we can do that. And also, anyone who has questions, like sort of think about any questions that you have, and we can also cover those when we're back. So yeah, we'll take 5 minutes. Earlier, I mentioned there was a screenshot. So just in case anyone in the recording wasn't able to see it earlier, I'll just put it on the screen now. So if they want to screenshot this screenshot, um, um, please, feel free to do that. So I just have it there. Yeah. So what comes next? Um, the next milestone we're going to cover is writing tests. So that is we write tests to check that things work as expected. So we'll write tests for our front end, and then also tests for the back end. So front end tests are like the user interface tests. Is this button where it should be? When I click this, does this happen? Or does a function run that like I've added it, right? So these sorts of tests. Backend tests are going to be like a bit more complex. Backend tests are more of the sorts where you can actually create a test database, and the backend tests are checking like uh, is my get request working as expected for my backend test? Is my post request working as expected? Like if I add and of course, we may actually need the get to test the post, because in that case you need to make a post request. You add, let's say, one entry to your table, and then you get your table, and then you need to check in that test, is that entry that I added the same one as the one I made in my in my post, right? So are these the same entry? So that's just one example of a backend test. And then after that, we'll be talking about deployments, some of which we've seen before, but will involve putting our application on a hosting service. Usually we like Render, Heroku. Render is a good one. Render is a free version, but there are many others. There's Heroku. Um, I think there are a few more. Their names escape me. Right, but we put our application on a hosting service so that it's running externally somewhere and users can just access with a link. So actually, so this is actually what I wanted to draw. Remember when I mentioned that the server was running on localhost? So I'm going to get a reference diagram. I think I have one. Oops. Let me just find it here. I'm going to use this reference diagram just to show what it can look like when it is deployed. Okay, so when it is deployed, like this will be the final step. This is like in about a month's time or so, maybe a little bit more. Yeah, definitely more, a month and a half or so. Eventually, we'll get something like this. So this container is our render server. And then now our backend is going to be inside the server. And that includes like all our files. And then one more thing, we make a production build of our front end. So that is our front end. So what happens is, and some of you might have actually already seen this, because I think this might have been part of the deployment for a React application on GitHub pages. But in project 2, we'll obviously go into more detail when we cover deployments. But what happens is that when our backend gets deployed, what we do is we make a production build of our front end. So that is what this little green container is. And what that means is like we condense all our front end code to just a few files, and we sort of just put it in our backend that we then deploy. This is our render server. And of course, we still have our database, which is actually outside. And, the connection to the database and back is still made. That still works just fine. And then all of this is what we see on our browser. Just put it in the circle, browser. And then this is on some link. So there's some website link where someone can see this. And so that is a user that's interacting with this. They're really interacting with the render server. So this is just a visual thing that I quickly drew of what it would look like when we perform the deployment, when we deploy our full stack application with a database connection. That's sort of what it looks like. Does anyone have any questions about that? Yeah, Samina?
I'm still not getting the render server part. So the render server is like for is it the render.com service that we use?
Exactly. It's not like I know it is kind of it's odd they use it's the same term as what we call in React to render, to re-render or render, but it's actually different. It's this one, render.
So, but this is for Postgres. What about for MongoDB? Because MongoDB doesn't use render.
So it doesn't actually matter. The database and what the server the database is being hosted on is not actually, it doesn't actually matter as far as our full stack application goes. We just want somewhere to host our backend and I guess the front end as well, technically, through that production build. We want to put our application on a server that's on the cloud so other people can access it because that server will just be running like always concurrently. It'll just be persistently running. And as
So,
long as it's running, someone can like see it and access it. We don't need to run it locally on our machine. So that's the difference. Instead of running our app on localhost, now it's running on some render like server address. Yeah,
so this the render.com has the feature to have our files on it that we can
exactly.
run on it. Oh, so we don't have to go through GitHub to deploy.
No, we will still often use GitHub to deploy because actually we to render will actually give it like a GitHub link and some commands that
Okay.
it'll use to deploy our application on its server. But
Okay.
we'll go
Okay.
more into those details and how those work.
Okay. Okay. Got it.
But yeah, actually, because you mentioned a good point, remember, we also technically, if we were using Postgres, remember that it was also on render because we can see here, this classwork database is on render. So render also has a built like on its server, we have a Postgres database. So one thing is that if we deploy an app and then that app is using the Postgres database that is also on render, so we're deploying on the same like render. sort of render service, we would actually use, remember those like database URLs, external versus internal? We would use the internal database URL because we are deploying our database on the same service render. And like it, I guess then it can understand it's like, okay, you're using a render server for your app. You already have your database Postgres on another render server, maybe like use the internal one. Maybe I can find a diagram for that. Let me see, like render internal database URL. I just want to see PostgreSQL. They must have I remember seeing a diagram. Yes, perfect. So this is an example here.
So
So
right now that we are using the external database. So when we do the front end and we go for the deployment, are we going to continue using the external database, or we will link our database internally to in like what you're saying, the database internally will connect it to the web server. So
yeah, we would,
will we switch?
I think we'd switch the URL to be internal because the database, the Postgres database is also running on a render server. And then our like application has now been put also on the render server. Yeah. And right now we're using an external URL because the database, yes, is on a render server, but our application is running on localhost. Like our server runs on localhost. It's not also on render. Alternatively, if we use a different platform, let's say we just use GitHub Pages to do the deployment, then we need to do, that's still an external URL because we have GitHub Pages. Our server is running on the GitHub Pages, but our database is on render. So that's still like they're separate platforms, separate services. I think the internal database URL, if it's all on render, maybe there's less the interaction between the backend and the database is much faster if they're on the same sort of service platform of render. And maybe that's why they provide that internal URL for that scenario. I'd have to read more about it, but that's just my hunch for why they have it.
I mean, if it is internally, of course, the time would be much faster for sure. But like you said, even when we are linking it, we are still giving it the GitHub link, right? Even when we kind of put it on the render. So
Yes,
our files will be placed via the GitHub link. So
exactly.
it would still be kind of accessing our services externally. No, I mean the database is there, but I mean, how will that become internal then?
I think actually yeah, that's a good question. Let's just see. I can't actually do a deployment right now. I don't, oh, actually, wait. I can. Let's just see. Okay, let me sign in here. I have a deployment on my own account. And so let's see. I deployed this application a while ago. And let's go to logs. Oh, can I just here build cache and deploy? So let's deploy it again. I want to see what happens. If it says, is it copying that information? Like, how is it doing the deployment?
Maybe it uploads the files from the GitHub initially, and then
I
it
do
has
think
it
that's what it
locally.
does because we have to tell it a build command and a start command. So when it does this build command, it is building the production build of the front end. And presumably, actually, it's making it on their own server. I think all the files. And actually, I think it does that here. Deploying using node, running npm start. Okay. Okay, I do believe that's what it does, and that's something we can double check as well. Yeah. Okay, I hope it actually redeploys. I hope there's no error that I made anywhere. Okay, good, it's live. Okay. So there is that. I think this is a good question for ChatGPT too. I can also just confirm. Alrighty. Does anyone have any questions about sort of anything we've learned this lecture? Uh, Okay, perfect. So in that case, let's go on our 10-minute break, and then when we come back, we'll start the lab, and we can just take any questions on any of the material that we have been learning so far. That includes, assignments, projects, anything like that. So yeah, let's go for our 10-minute break.